Good afternoon, and welcome to today's webinar, Driving Profit Through Operational Rigor and Data Visualization, presented by Plex, a Rockwell Automation company, and hosted by Metal Forming Magazine. My name is Lou Kren, Senior Editor at Metal Forming, and I'm pleased to be today's moderator. Before we get started, just a few notes about today's GoToMeeting session. This meeting is being recorded for archiving, and the recorded event will be posted to our website within the next few days. We'll let you know via email when the recorded webinar is available for viewing online. Also, all participants in this meeting are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your side during the program. However, you do have the ability to communicate with us throughout the program by submitting your questions and comments using the question box located on the right-hand control panel on your GoToMeeting screen. Simply type your question to an organizer as selected from the drop-down menu. You'll also use that same question panel to ask questions of our speakers at the end of the presentation. Now it's time to begin today's webinar. Defend, protect, and sustain are the new call to action for today's smart manufacturers and requires business intelligence. Do you have the actionable insights available for taking decisive action? If your data is not accessible from the plant floor to the top floor, then you are leaving working capital and resources at a standstill. In today's webinar, Ben Stewart, Vice President of Product Strategy at Plex, a Rockwell Automation company, will share how you can execute a smart manufacturing strategy to optimize data, resources, and processes for the best profitable outcome. Ben Stewart is responsible for product strategy at Plex. He collaborates with company leadership, customers, and analyst community to shape the future of the Plex manufacturing cloud. Ben brings strong domain expertise gained in his previous roles as CIO, ERP consulting manager, and global IT director for 3 manufacturing companies and a leading technology consultancy. He also served as president of the Plex Michigan Users Group and has led ERP implementations at over 50 locations worldwide. Ben earned a bachelor's degree in finance and operations management from the University of Massachusetts and an MBA with a focus on management information systems from Oakland University. Ben also is the author of MES for Dummies. So without further ado, please welcome Ben Stewart.
Great. Thanks, Lou, for the introduction, and I'm glad to be with you today. Got a lot of wide variety of content to go through today, so going to take a look at the various topics. Get a little introduction on myself just to add to the commentary that Lou had. Some key takeaways. Look at the manufacturing stack that companies are using across what we see across the industry today, specifically through a lens of what Plex has seen. And then I'm going to take a deeper dive into understanding cost drivers. Going to try not to get too financial. I think looking at the registrant list, we have quite a wide variety of people on the webinar today, from finance to operations, general management, engineering, a wide variety of roles. So we'll keep that at a high level, but we'll dig into some of the cost drivers there. Talk about production and efficiencies, what we see when we visit various plants and customers, and then talk about that operational rigor that's needed to really help shore up that data so that you can get good information for management decision making. How is that visualized, and then kind of getting it done? How do companies get started for that? So as Lou mentioned, yeah, I've been in the Detroit metro area for most of my career, working either for manufacturing companies or for software companies. And then specifically the last 15 years working on MES and ERP initiatives, have launched specifically Plex, but also supported other custom MES, other SAP, QAD, other types of software that you'd be familiar with through those times at various manufacturing companies, mostly in automotive and industrial manufacturing is my background. And then, Plex was acquired, as many of you know, most of you know, last year by Rockwell Automation. And so that really expanded Plex's reach down into those control layers. We'll look a little bit at that today when we look at the technology stack. Currently lead the product strategy at Plex. And we'll have a link at the end if you want to download the MES for Dummies booklet. It's got a lot of good content in it. Talks about different aspects of automating and controlling your shop floor. And so I'll show a link at the end where you can get that free download. So as we look at the content today, some of the focus points is going to be kind of what are those tools that can help you collect and contextualize that data for decision making. How can you sift through that data to find margin improvements and to be able to take out inefficiencies? What are some of those common obstacles that we've seen and how do customers address that? What does that data look like as it's visualized so that you can use that readily? And then, as I said, where to start and what to expect. And you can see from this quote's one of my favorites around data and trying to move your organization from gut feel and opinions on what we should do to having the data in hand so you can make solid decisions based on empirical data. So as we look at the manufacturing stack, you're probably familiar with ISA 95 framework and taking you through level 0 down at and level 1 down at the machine level, where you've got controls. Now, Allen Bradley, of course, is the famous brand from Rockwell, but really this is any kind of control device, PLC. This is that data that's flowing off of your machines, and that's there's a ton of data there. Often that's not very accessible. It's often in historians, or only a few people have access to that, but that can be very important data to get your hands on so that you can put your operation in context of that. Because as you move up that stack and you start looking at level 2, level 3, kind of where an MES system, a manufacturing execution system sits, and then all the way up through ERP, those are things that as you look and see, why did we have bad quality? Why was production not at the level we were expecting? Why are we behind? Why did we have to change the production schedule? A lot of times those are things that have relevant data closer to the shop floor that you can capture much of that at the MES level. We'll look at a little bit more at that today, but can give you data in context. So say you had some bad parts that were found through the quality checks. And you could tell through an MES, who made those parts, what work center, what time, and you can get a lot of great information from an MES. Data in context as you look at really figuring out the root cause of that. If you've got this data coming off the machine, say you could see what temperature's at or what the conveyor speed was. If you've got, say, something going through an oven or something like that, so you could really get to see. Okay, it was running too fast or the temperature never got up to the right level. And then you get to be able to put specific production lots and produced material in context of the machines and what they were doing at the time. So having that fully integrated view is really important. And whether you're getting that through a single company like we offer, or a lot of companies, we know a lot of plants, right? You've got a collection of controls and solutions and devices over a period of time to be able to collect that information together, to be able to see that in context. And often what happens then is as those data silos exist, it becomes harder, as you know, to then make good decisions. If you've got a production plan, but then you've got a bunch of material gets quarantined, either incoming material or WIP. As I mentioned, some of the machine data of how the equipment is operating, is it producing good product or not? And then you need to be able to see that alongside the inventory and the production planning to be able to adjust appropriately. So as we look, when companies come to us and start asking for, hey, I'm thinking about an MES or starting my digital transformation journey, we get a wide variety of needs that companies are coming with. A lot of times that does start with visibility. Companies are looking for, I just need to see if my machinery is running. I need to be alerted if it's down. I want to see if it's running at rate. And they move from that into control, and they want to be able to control that process, not just see what's going on. And then they also want to automate it. So as we look at the products that we put out into the marketplace for that, we try to align with those. So something like production monitoring, where you can see what's going on, and we'll look at an example of this. And if it's running at rate, asset performance management, this is basically IoT. This is those sensor feeds coming off of the equipment to see how is that machine performing. And this is usually two major use cases. This is kind of machine health. So does the machine heading toward needing maintenance, or is my machine operating within tolerances to make good product? As you start to look at a quality management solution, this starts to bridge that gap. So not only can I see it, or is my product meeting my quality requirements, but I want to control it. I want to make sure I don't make any bad product. I want to make sure that all the steps are fulfilled, that all the tolerances are met. So I'm controlling that process before it gets through the manufacturing process, or certainly before it leaves my plant. And all of those then add into an MES, a manufacturing execution system. So to be able to then control inventory, do traceability, all the things that come with an MES, and we'll be looking at more of those today. Quality is an integral part of that, and then these kind of how is everything running, but really can add the MES layer that picks up that additional traceability, inventory control, production planning, all of those things, storage of the material movements. And then as companies, a lot of these things can be achieved through operator interaction. So some kind of control panel near a machine, so if that's a stamping machine or that's an assembly area or weld cell, where an operator can interact with that. But in cases especially where you've got higher takt time, you've got product that's flowing more quickly, or you've got maybe a more sophisticated piece of equipment that is producing a lot of good data at the time that product's being made, you want to be able to capture that directly, and you can then drive those transactions directly into the MES or into the quality solution, also into APM and into production monitoring, so that the machine drive those things in, so that you're not distracting the operator. They can focus on making parts, right? And then across that, you can have ERP. Now, a lot of companies, Plex is a little unusual in that we offer ERP with MES and QMS. That's what we've done for over 25 years. Now we have carved that out so that the MES can be, if you say you've got a big investment into a large ERP like an SAP or an Oracle, a lot of companies aren't ready to change that. You can just have an MES. You can integrate to any other ERP, but if you get it all together, then everything's connected and there's no integration effort there. Some of the screenshots we'll look at today in terms of looking at driving profitability will be through our cost accounting screens, where you can see that level of detail. So let's take a look at those cost drivers. So I mentioned when companies are coming to Plex, they're often, they're looking for visibility. They're looking to control quality. These are very typical things that we see companies experiencing with poor visibility of inventory. What's my WIP inventory level? If you've got just a normal ERP that's mostly financially minded with purchasing and sales, often you're receiving raw materials and components, you're back flushing finished goods, but you have very little visibility into that WIP inventory and where things are at in the midst of your plant floor. And so people are sending out cycle counting crews and daily or shift basis to really see where are my inventory levels at. We've certainly seen this exacerbated through COVID and supply chain shortages. Most, I should say most, if not all of our customers have been impacted by, as I'm sure you have too, by supply chain shortages and trying to pivot, trying to produce other, what can I make based on what I have? It's led to inventory levels rising, companies holding more safety stock because of the disruptions in the supply chain so that they don't run out of material. So all these gains that companies have made over the years or decades of trying to slim down and lean down that inventory have reversed in the last year or two as companies end up having to stock up additional inventory. Certainly manual processes and operator errors Another outcome has been that, generally everybody is short of people and there's a higher turnover. So as you're bringing in new people, they haven't been trained as well, or they've just barely, just been trained this week, and they've got to get out there on the shop floor. Operator errors are more common. It's hard to enforce quality standards, get people to do things the right way. In addition to maybe any manual processes that you have that were never automated. So, a lot of often when we're coming in and we're talking to companies about an MES, they're doing their shop floor controls on spreadsheets, on paper. The quality data is getting recorded offline. And so those are things that aren't real time. They're not integrated. It just increases that opportunity for error. Not seeing scrap and waste on a timely basis. Maybe they have another system, but it's like the silos that we talked about at the beginning where that data is not connected. So all those things are issues that we're seeing manufacturing plants experiencing, things that have existed for a long time. Some of those have just been made more prevalent through the inventory and people shortages that are going on today. So let's take a look at kind of how you can start to get visibility into those. And so, what you see here is this is a screenshot of a cost accounting screen. And what we're doing, what we're going to illustrate here is as you look at, say, on the left-hand side here, you can see different operations that get performed, say, in a manufacturing process. And, at a basic level, right, that these steps must be performed, and you need that MES to force these steps to be performed so that people can't skip a step. So when they go to execute these on the shop floor, you can't skip one of these. But then also, a number of different cost drivers would be associated with that. And you can see in this case, we got two different labors. We've separated out the production labor with the cost to do that. Setup labor is separate from that, so you can tell what's my ongoing run versus each time I do a changeover. Overhead production rates, once again, overhead setup, and then the material costs. And then you can see over here on the right, and I think the next slide has it zoomed in a little bit here. You can see that there are then calculations. Now, in some cases, these could be you could be uploading these rates. You probably have all these cost elements defined for each of your products. Now, what I found with most plants that I've implemented at, those are often 2, 3, 4 years old. People look at the rates like, it's way out of date. So you definitely want an ability to update those. We often, when we're digitizing, we're going to a new system. That is one of the efforts we go through. Is that okay? Maybe we're going to load in what we had before, but what's planned to, once we have now all this new data flowing in on the actual time it's taking people to do things, actual numbers that we'll look at in just a minute, then we can update these standards so they're more accurate. And so the system has the ability to take these variables and then calculate these things and then let you adjust those as you go. So as we look at some of the ways that you can use this data to start to identify these inefficiencies. So here's an example of like a rolling average rates report. So you can see in here, and this is test data, so don't put any stock. Don't look at the numbers too close because they'll look dramatically different, like a 99.6% variance. But basically, what you're seeing here is you're seeing at various operations the idea that we know through the software, then through the MES, how many parts were produced by people clocking in to that work center and all the people that are working in that work center clocking into it. We know and we count the hours in terms of, we're not asking people to fill out timesheets. We're just saying, they started working on it now, and then they stopped at this point. So we know the actual number of hours that were collected. And then we can look at that standard rate, that generally that pieces per hour, and we can start to see, where are we having variance on what actually occurred with the number of parts we actually made, with the number of hours logged in compared to the standard, and then start to look at, one, is there a pieces per hour variance there? And also, are the number of people that are clocked in, is that significantly different? If we we thought there was a crew of 3, but really only 2 people are clocked in because we're short of people and we're chronically short of people, then you can start to see where, maybe the production rate should be a little lower because we had fewer people working on it. Or if we've got the right number of people, why is the production rate low, and can start to tip you off. You can also look at that in another view here, where you are seeing both the standard rate, which you would use for your counting practices, but also there's other buckets for target rates, ideal rates. These could be, hey, when I'm running at full efficiency or based on the capacity of this equipment that I've purchased, maybe a rate that was quoted to the customer. So then you can start to compare against these different, standard, target, and ideal, and look at the actuals compared to that. I mentioned the crew already and the difference that the number of crew can make in terms of you want to always make sure you're taking that into account if your staffing is higher or lower, unless you've got a 1-person machine that you're working at. So then, as I mentioned, once you're collecting this data, and that could be, certainly most companies update their standards on an annual basis. But you could have that ability to update that. I know with our system, we allow multiple cost models so that you can make adjustments. You could have an annual standard that you measure to, but you could also update it each month and have a different version and then compare to those different versions of the cost model as you go throughout the year. So you don't have to make it just an annual exercise. So it's important to note, so that was a little bit deeper dive into the accounting aspect of that. But as you look at why operational rigor is important, there's a lot of data coming in. You want to make sure that that data coming in is accurate. So as we look at, we have these different cost algorithms here and the data coming into those. We have to make sure that that's accurate coming in. So often, right, you walk out on the shop floor and what do you see? You see a lot of whiteboards. You see people putting in production counts per each shift or each hour, which of course that data, unless somebody's capturing it down, then that level of detail gets lost, or it's a manual process to capture it. We found one of the really important ways to improve this is to shadow people on the floor, and it's interesting to often get the conference room view of how a process works, and then you go out and you actually watch someone do the process on the floor, and you find out just how big that variance could be based on what they've it's evolved over time. Maybe the standard was never updated, or the steps that the person's going through as they kind of made it more efficient, or weeded out unnecessary steps, or they're doing steps that are unnecessary that nobody ever told them they didn't need to do anymore. So walking the shop floor and watching a process in real time is definitely an important part, and finding out where are all the places that people are either capturing data or data's not getting captured at all. And so as you look at these obstacles to getting that accurate data, and whether that's timeliness, accuracy, these different systems where it's getting collected, we know, as I mentioned in the opening, that part of this is your process, and then part of this is also these new people that are coming in, and this kind of constant turnover on the shop floor, and that those things will, if you have a good process or a partially good process, those things are going to add to that, add to the data not being as good. Certainly not having enough hardware. If you are asking people to capture things, scan things, you don't have enough scanners on the floor, you don't have enough places where people can easily input that data, then they're going to tend not to, the more difficult it is. Have definitely seen in implementing, especially as companies go to do things digitally, and it's maybe capturing their name through their login and what was done. People are a little nervous anytime we come in with new software and new automation. Usually the first thought, fear of the unknown, is they're looking to replace my job. They're going to automate this, so they need less people. yeah, I don't want my name associated on this because someone will see if I did something wrong. And so those are things that by having good communication with the shop floor, you can really get them to trust more that, you know, that these are things to help them do their job, make things go more efficiently, and they're not things that people need to be nervous of and then purposely avoid. You know, as we look at material data, you know, this is data that, like I said, often on an ERP, you've got just the raw components, raw material coming in. But really, to really get good control of the shop floor, you need those real-time production counts, both at the beginning and end, and those WIP processes, especially where you're accumulating WIP inventory in the middle. You know, that real-time scrap information. So if you all of a sudden don't have as much material available as you thought you did, you can also capture cell setup. So if you're not recording, you don't need to record production or consume inventory at every single step along the way. You may have or planned production, right? If you've got you know, your plant floor is set up where you have flow from the beginning to the end. A lot of that times, right, you want the material to naturally flow through the plant through a push or pull. Maybe you're using a Kanban system, and so you know, you don't have to schedule each place. There's usually going to be portions at the beginning and key steps where you do need to schedule. You do want to check inventory where you've got maybe a natural accumulation of inventory. Other places where it's just flowing right through, you can just set those up so that labor, that material just kind of gets consumed as it flows through once it gets to that stopping point, that backflush point, wherever that might be in the middle. Supply items, also, you know, these are MRO. So these are things like whether that's packaging, weld wire, different things that you're like, that's really not a direct material, but it is an important part of the manufacturing process. If you don't have it, you can't make things in your normal process. Those are often missed and cycle counted, but the ability to connect those to a bill of material, you know, treat those separately. So if you're shipping internationally or you've got declarations on what is actually in a product, but the system can be set up so that you're consuming those things automatically as you produce if you have standard quantities, so that you don't kind of fall behind or miss reordering something because it's not getting used in a real-time environment. You know, a lot of the things, right, you're tracking material by labeling and scanning. You know, ISO TS standards, right, you've got to have everything labeled anyway, but to make sure that everything is labeled at the time it's changed or that it's produced or consumed. And then just making that a light touch so that people can easily just scan things as they go and they're not having to spend a lot of time on the computer. Certainly, one thing I've seen from implementing over the years is that we would often launch and we'd have a larger number of people who had the ability to adjust inventory. And that was always bad. Sometimes necessary right at the launch to kind of get the kinks out as you go, but certainly you want the people that are responsible for the inventory to be the ones who can make the inventory adjustments, because people will, if there's a discrepancy, something short or there's more, you know, they're going to take the path of least resistance just to clear that up and keep moving. And you want to make sure you've got the right permissions on who can adjust inventory so that your inventory stays accurate, and then still have a regular cycle counting process so that you're double checking and getting your accuracy and ensuring your accuracy as it goes, so that so you can plan appropriately. Labor tracking, I mentioned that the ability to capture labor as you go. So certainly you've got your process, right, where people are clocking into the plant and they're clocking out, but an ability to capture labor at various production points throughout your plant, so you know who is working on a work cell, how many people, how long they're working on a job. You want that electronically captured to drive those cost models that we looked at earlier, so that you know exactly how much labor is going into each step and into each product, so that you can then make adjustments and know which are the most profitable, most expensive, where's your labor going, and also so that you can, you're collecting scrap and production rates at that time too. But being able to link that labor more than just here's who was here that day in the plant, is super important. And then as you are recording production, to capture that, making sure you have enough hardware out there that people understand it, that it's set up so that it's easy, it matches the actual production process. And operators have a way to, a lot of times whether they're saying, oh, this looks suspect, or whether it's scrapped, or that later on goes to a quality department, that you're mirroring what has actually happened in production and kind of the natural flow of things through your plant, that you're capturing those as they go, and then also capturing employee suggestions, so that as employees say, well, I'm doing this, but this doesn't make any sense, or I could do this faster, that you're able to capture those things through a suggestion system that's easy for them to use and for you to evaluate. Here's an example. Instead of writing up production numbers on that whiteboard out on the shop floor, where if you've got that machine is connected to the MES and you're capturing counts, then it's very easy to then just have a display board that is showing for each hour what was the planned number. So for a particular job or part number, what was the planned number to be produced, how many were actually produced, cumulative amounts, and then if there was downtime on that machinery. So, they missed the production count, well, because there was additional downtime or there was scrap. And then you can have an ability to actually capture notes from an operator that might have once again been written on that whiteboard and then lost thereafter, but that they can do those, and those get stored so that people can see kind of what happened, what were the misses, and why. So in addition to those things, kind of capturing production, Workcenter Health really starts to go, if you think about the machines on your floor, and some of those machines are those ones where there was those natural recording points. It's I've consumed, say I've got a stamping press and I've turned coils into parts, and clearly that's a place I would want to capture. I've made a bin of 5,000 parts from this coil. I need to know that. I need to know those are ready and available. As I kind of go through the production process, as I said, I might have an assembly cell. Maybe I don't care about every single cell, but I care about at the end of that assembly process, what's been transformed into this new whip part. But certainly the equipment can be those same work centers, or it could be additional ones. So the idea that you are capturing now sensor feeds, so IoT data, this is asset performance management. You're capturing data from those machines. On the press, that could be, how fast is it cycling? It did cycle. What pressure is it at? Things like that. If you've got a heat treat process or an oven, what temperature is it running at? What speed is the conveyor going through there? These can also be other kind of auxiliary pieces of equipment like air handlers. So if you got a paint booth, it's not you're tracking how many parts go through the paint booth, but maybe you're able to have a sensor on the exhaust air or on the filter to make sure that is okay, so something doesn't become clogged and then cause an issue. So lots of different things you can measure, and then want to be able to see those in context there. As you look at, we call ours automation and orchestration, but this is basically saying I've got data, I'm recording production. I want to automate that, so the machine is recording production instead of the person. It increases your accuracy. It tells you when the machine is running or stopped, and that's something that's easy for an operator to forget. They have a breakdown, they run out of parts, they forget to change the status. So it's nice to have them have a way to be able to do it, but you certainly get better accuracy if you have the machine letting you know immediately when it stopped running. You get to see those micro stoppages, but then also an ability to orchestrate that. So what I mean by that is, say you've got a machine that's making parts, it's counting it up. When it gets to say in this case 100, it's a standard pack. You'd normally get a label, you put that on there. The machine is maybe even able to do some quality pieces where it's rejecting parts as you go, but for whatever reason, some of the parts that it passes, it says are good. The operator does a visual inspection and says, oh no, these parts aren't good, I need to run them through another time. Of course, that would make the count all get off. Machine doesn't know they picked up one, they put it back through. And so the ability for whether that's a little interface or for the operator to say, oh yeah, I had a bad one, I either scrapped suspect or I reran it, and have those counts get adjusted. And you want to be able to do that as sort of that orchestrate part, that usually what's happening on the floor is a little more complicated than just what's set up in the book in terms of the production process. And then if you've got something additional that you're doing, maybe the software doesn't even normally support that, you've got a rework process or something, some ability to extend and configure so that you can make sure that you can capture the actual flow of material and activities. So what does that look like as you're collecting this data? So here's an example dashboard of from the production monitoring, that first level of visibility I talked about. Now this is just a standard screen. Picture this running on a flat panel on the shop floor. This is hooked up, say, to that stamping press, and it's showing based on the part that's running. The MES knows what the target rate is, like we talked about. Knows how many are actually getting produced, the cycle time, and you can see down here at the bottom if there are downtime or stoppages, micro stoppages, and these are all widgets, so you could rearrange these to be what you want them to be and know if you're hitting your target production rates or not. This is something that installs very quickly. We can usually stand these up in a matter of weeks, and then you can kind of, you don't need these, you probably wouldn't put these on all of your equipment, but on key ones where you want to make sure that this piece of equipment is a bottleneck, or this start the process off, or it's an expensive piece of equipment, and I want to monitor if I'm really running it as much as I think I am. So parallel to that is this piece I talked about, asset performance management. So this is now not just periodically the machine is cycling and producing parts, but this is this time series data. This is sensor feeds. I mentioned the air handler on the paint booth. So these are where you're now got this series of data. Maybe these are coming in every minute, every few seconds, and it's taking a measurement through these sensors. It's streaming it up into the cloud, and then you're able to put alerts on there. So if it moves outside of a threshold or a range, then you can be notified of that. So to keep you from making bad parts, somebody gets notified that this isn't performing correctly. You either need to take it down for maintenance as soon as you can, or you need to stop immediately, or you're going to make bad product. And so this asset performance kind of goes along with that production monitoring. Another visualization. Now this is a little less visual, but in terms of fancy graphs and charts. But once again, this that reporting that we looked at, that's highlighting for you in red or green or yellow if things are starting to come out outside of tolerances in terms of variances. This one doesn't show that. Fantastic, because everything's bad. Hopefully your plant's not running like that. But reporting that highlights exceptions, so exception-based reporting. Similarly on OEE, so you've got maybe the real-time version that's on a flat panel or a tablet, but something that's looking over time. Things like a daily shift report, how did we do in each of the different work centers? What was planned for production? Did we attain that? And so something that gives you good summary level data, either at a plant manager or a line supervisor level. Variance reports, so where were the big variances on either material or labor? Highlight for me where I'm getting the most variance at, and then determine, is it because my standards are wrong, or because something's changed? I'm staffing with fewer people, or something's taking longer, my material's not working as well as it used to, my machine isn't working as well. So variance reports. Production status dashboards, so you could look across your plant and see not just how one particular machine is doing, but how are all the different work centers. You can see in this view here, I've got multiple work centers. I can see what's going on there, what job they're working on, what parts they're making, and are they on track or not? Is the machine down? Why is it down? And to be able to drill in, so you can kind of get it at a glance, see what your plant is doing. And then this is maybe analysis that you'd be doing more periodically. So once you're now collecting downtime, whether through a machine or through an operator, what are all the reasons that I've got downtime? So if I look at this downtime tracking analysis, I've got, the amount of time, 65% of the time I was in production, I had downtime, big chunk of downtime, 20% over here. I had maintenance, I had setup and changeover. Okay, maybe that looks pretty reasonable. Okay, why was I down 20% of the time? And then to be able to drill into things like that. And this is where the operator would have been prompted anytime they put the system down, say, well, why is it down? Oh, it's a material issue. It was, I didn't have material. So what are those reasons? And then you can start to find out. And if you've got a big unknown like here, maybe you don't have the right reasons available in the system for them to select. And so you can start to drill in it and start to get that operational rigor in there to collect that good data. And then finally, some analytics. So then as you can start to see, and maybe you're a single plant operation, or maybe you're multiple plants, so that you can start to see maybe on a more monthly basis. And now you're kind of taking it up a level to a higher management level, and seeing, okay, well, what is my OEE at, kind of across the plant, or being able to drill down into specific plants, downtime and scrap, and then also be able to compare that if you've got multiple plants kind of across plants to see how you're doing. So it's a lot of different things. So how do companies get started? What are they doing to get this done? And another quote here, right? That if you don't have these analytics, right, you're guessing, or you're taking people's word for it. I know I've had times when we were implementing, we had plants that were running, say, overseas in China or India or even Europe, and I didn't have access to see that data. And so you'd ask someone, well, hey, we're running behind on these parts. Hey, they say they're running 24/7, and then it's not until you actually get that data coming directly in that you can see it. Maybe find out that some of those machines are running 24/7, but many of those machines are idle. I'd heard from people, oh yeah, it's gonna be hard to implement at this plant. This plant's running, 24/7 around the clock to keep up, and you go out there on third shift in the evening, and there's one machine running. There's one machine running 24/7 maybe, and the rest of them are not running at all. And that's important information to know, right? So if you could really free up that machine or improve its efficiency, maybe you could up your throughput dramatically. But you don't know unless you can actually see the data going through there. So as you look at where to start, so a lot of companies, I mentioned shadowing on the shop floor to see where some of the issues are. Identifying those key pain points. I'm sure you know what your key pain points are. It's scrap, it's lack of throughput, it's lack of visibility to inventory and WIP, insufficient quality controls. Identify those ones that would make the biggest impact. You can also, like we do, a free engagement to do with a value engineering team, where we can come in and look at those areas that you want to improve. We can give you benchmark. We subscribe to APQC industry standard data. So kind of what does a company like yours, what kind of OEE and scrap rates and inventory turns should you expect? That's kind of benchmark for a company like yours. And then even better than that, kind of what are companies achieving like yours if they're using our software? Because we have that data kind of anonymized in the cloud, so we can say, hey, we had companies that were doing this, and now they're able to do that. And then you can run a pilot, right? See where, hey, I think I could make the biggest impact here. I can justify this with an ROI. I'm going to start here and try this out. So some examples of what companies who have gone digital that are implementing, that are putting in these kind of controls. They're kind of these metrics are kind of all over the board in terms of where they focused, but whether that's being able to grow and scale faster, whether it's reduction of scrap, it's reduction of inventory write-offs, because of being able to better plan production, being able to hit 100% on-time delivery, or just inventory accuracy in general, and being able to have very accurate inventory because you've got control of what's going on, and you're able to measure at all those places through the process. the ability to do traceability, to do whether that's mock recalls or to look and see if you have problem components. I mentioned inventory reduction already, or improvement in outputs, and the ability to basically take some of these things, these processes, and be able to launch those quickly so that you can start getting value, and not a long year-long implementation where you're waiting to see value, but be able to put things in quickly and be able to start to see results. As I mentioned at the beginning of the session, there's the URL down at the beginning, down at the bottom right corner of the screen. You can go to plex.com and you can get that digital download of the book. It's got a lot of other great detail in there about ways that companies are kind of transforming their businesses through MES and digitization. You can see some of the different topics that are covered in there, and you're welcome. It's a free download if you want to go get that. And with that, I will open it up for questions. I haven't been monitoring the chat, but Lou's going to come back on and see if we have any questions.
Thank you very much, Ben. Yes, it is time for Q&A. There is a question panel on the right-hand side of your screen. Feel free to use that. Any questions, and we'll certainly bring those up. Ben, there's been, over the past couple of years in terms of software as a service, a discussion between on-premise and cloud SaaS. Can you maybe illustrate some key differences between the two? Yeah,
and I'd say this. So Plex is cloud-based software as a service. We see a lot of advantages for customers there, where they don't have to maintain servers, they don't have to maintain technical people and programmers. We're able to rapidly scale with them. It doesn't mean that there's never a place for on-premise. So on-premise systems often, though, can get out of date. You got to patch them, you got to keep the hardware up to date. But we have found that there is a hybrid of those. So we have edge components to our cloud. These are pieces that, so like for production monitoring and asset performance management, automation and orchestration, these are software components that would install on a server at your plant. They're generally a very small footprint, and they are to then connect to those PLCs to allow those machines to feed that data to that local server, at high speed, let you collect that data there and then stream it up to the cloud. And so then by having that small footprint, it's on premise, so it's very fast and responsive. But then we kind of handle everything else as it streams up. And then we're able to give you the analytics and the growth and innovate and kind of continue to release new features on that once you've collected that base information. So we think a hybrid approach makes sense as you start to automate, but with the bulk of the software and the data up in the cloud, so it's easier, it's more transparent. You're able to kind of break out of those silos and see all the data kind of across your operation.
Mm-hmm. Okay. And when implementing Plex, how would users integrate their current application landscape?
So most software companies, we certainly have a big suite of APIs, application interfaces. So there's a developer's portal. So we expect that companies are going to have other software that they need to integrate with. So say you've got a design system, a PLM, and you want to stream in parts, bills of materials, routings. You can stream that master data in to the system. If you do have a top level ERP, like an SAP or an Oracle, and you want to bring in raw material or finished goods that you can ship out, so we can connect there at various points. Certainly you could use our full integrated suite, but if you're connecting to other software, so basically through those APIs, you can trade that real-time data back and forth.
Mm-hmm. Okay. And the last couple slides you had, it showed some very impressive improvement there as a result of the data gathered and the actions taken and the analysis. Could you go over again some of the kinds of improvements and metrics that companies can see from using this software?
Yeah, I'd say probably most common things that we see are certainly an improvement in inventory accuracy and control. So our software in particular is serialized inventory. So companies get a very fine level of detail in terms of where is inventory at each operation step, at each location. And so a high level of inventory control that can help you with reducing your inventory levels and increasing your turns. So, as we mentioned, I mentioned at the beginning that inventory levels have gone up because of supply chain disruptions, and you may have some stuff you just need to inventory more of for safety stock due to those disruptions, but you do get a lot more visibility to that. So where you can start to trim back, you can. We do get a lot of companies that are also seeing advantages to advanced supply and demand chain planning. So I didn't really talk about that today, but there are, we have a product demand caster. There are products out there that then will let you look at, let you run what if scenarios. If I'm short of material, what do I do instead for a production plan? Regenerate that production plan based on that. But so those are the kinds of things we're seeing customers benefit from. Certainly inventory control, better visibility to scrap and being able to control that. Certainly production rates, companies that are even just putting in production monitoring or APM are able to see, hey, I thought these machines were running. We have companies that thought they had a downtime issue, and it turned out that it was really just a slow throughput issue. The machine wasn't running as fast as they thought they were. They weren't, either because of the operator or the machine itself. And so really until they saw the data, they were actually focused on the wrong problem. So companies are able to get that better information and be able to adjust there.
Mm-hmm. And you also talked about companies getting started. Is there maybe a base level of maybe on-staff capabilities or people or IT staff or equipment or data gathering that companies should ideally have in place, or what do you see out there in terms of people getting started with, or how do they make themselves ready for that?
Yeah, I think that's a good question. We found companies are all over the map, and it is funny, even in the big name companies that you see and you think, oh, that sounds like a company that's got it all together. You get into their plants and you find a lot of manual processes, you find a lot of old equipment, and you find that a lot of companies have, because they're focused on running their business and they haven't necessarily made investments into technologies over the years, and so they're trying to get caught up. So we're very used to seeing a lot of manual processes, but that's okay. The good thing is that the technologies have gotten cheaper and easier. We go with a configuration type of approach where you don't need to come in and customize. You can buy off-the-shelf hardware. You can choose, which parts of your plants you would automate, which parts maybe you'd leave a little more manual, just interacting with a browser, still capturing information. So you can kind of scale kind of how much hardware you need to buy, how many places do I want to put PCs on the floor, where do I want to scan stuff or not. Some of that, as you try to control the process, we'll give you guidance around that. But so to make it achievable and say, okay, based on your particular metrics you're looking for, the areas you want to improve, these are the areas we should focus on. You should, whether that's monitoring or quality or the whole production MES process. Where do you focus the time and energy? It's modular, so you can kind of start at the right place, and then how much hardware and technology do you need to support that? And then you can evolve. You can do that in phases. Start off with something straightforward, and then start to automate and really fine tune that as you go.
Mm-hmm. And obviously, there's so much talk about cybersecurity with the cloud and with so much data gathering. Can you talk a little bit about maybe cybersecurity for this type of technology and the ability to repel or avoid cyber attacks?
Yeah, it's certainly critically important. That is another advantage of cloud actually over on-prem. Someone who used to administer as a manufacturer both cloud and on-prem. It's hard to spend the cycles to get all the security in place, keep all the patches up to date, do intrusion testing, and make sure everything is up to the latest to be fully protected. with a SaaS offering like ours, we have people, that's their full-time job, right? We can afford to employ people to do the intrusion testing, to make sure everything's on the latest and greatest patches, keep making sure that our technology stack, like we had gone out to our customers in the last year and said, hey, TLS, a protocol that's used by these scanners and equipment, there's versions that are out of date, they're not secure. You need to get on a path to get to the latest version because it's a big security risk. And so we kind of shepherded our customers through that, made them aware of it, got them to the latest versions that were safe. And so we are, they hate it when I say it, we are have not experienced any kind of hack or ransomware. And we spend a lot of time and effort to make sure that our data is secure. We have had customers that have experienced those in other systems, and because Plex was accessed separately through the browser, Plex was not impacted, even though their on-prem systems in some cases were compromised. We were able to help them with the data they had in Plex, kind of get things back up and running. But it's certainly a big concern is on the rise across the landscape in terms of hacking and cybersecurity awareness. Rockwell also does some things with cybersecurity around the OT layer, around making sure that those hardware devices are also secure, kind of outside of the software space as well.
Mm-hmm. Well, and then one more quick question. At the end there, you mentioned MES for Dummies. Could you give a quick maybe thumbnail of what readers of that might come across and how they can receive that?
Yeah, so just real quick, the link down here in the bottom, you can find it. I think when you go on the Plex website, you'll find it down at the bottom of the website under resources. But yeah, basically you'll see some of the chapters that are out here in terms of why an MES, how companies are digitizing, ways to improve visibility, kind of what the landscape talks about. And this could, we'll have to be rolling out an update in the future too, is some of the things, even production monitoring and asset information, we touch on those lightly, but those continue to get easier and easier to access. And then also kind of a little bit of what we talked about today on the last bullet in terms of where you get value and how it can drive profitability to your bottom line, areas that you can focus on. So a little expanded discussion on that, more than what we even talked about today.
Okay. All right. Well, thank you, Ben, for that outstanding presentation today. And to our audience, thank you for attending today's program. We hope you found it to be a valuable experience. Once again, an archive of the program will soon be available. When it's ready, you will receive an email from us. Then you'll be able to review what you learned today and share it with others within your organization. You may close your browser now. Have a great afternoon. And thanks again, Ben.
Great, thank you.